Well, this is me after doing the video, and just wanted to put this at the beginning just so you don't waste your time. Um, I have no clue what I'm doing, and I'm kind of winging it. And I made some mistakes throughout the video, but I'm gonna roll with it. If anything, maybe it's useful for somebody else. Otherwise, I guess you can laugh at an idiot who has no clue what they're doing. Um, at a minimum, if you do decide to watch it, you probably could watch it at 2x speed to save your time. But either way, hopefully you enjoy. So it's been some time since I've taken this desk controller apart, power supply, whatever you want to call it. And I'm starting to get irritated with not having a height adjustable desk when I paid for a height adjustable desk. So I'm going to do some poking and prodding and see if I can determine anything with this. I don't really know where I want to start though. Just trying to think here. I think the first thing I want to do is figure out what the ground points are. I don't know which ones of these pins, which of these pins are ground. And I also don't know which pin on this power connector is ground for the power cord. Ouch. I'm going to guess it's the one in the middle, the big one, but there's one way to find out. Alright, yep, it is ground. I just checked from the ground pin on this to the ground pin of my power strip. So knowing that, I'm going to guess that this here is ground on the power supply. Yep. And I think what I want to do is I want to trace the ground through there, but I should probably document that on a piece of paper or something. Alright, so I got a piece of paper here. And I'm just going to do a rough drawing of the layout. And I think what I'm going to do is I'm going to use that ground pin as a reference, and I'm just going to start poking at some of these points of interest. So these two are ground. I'm guessing there's going to be a voltage coming out of those two. Interesting. How many pins are there? 1, 2. 7 pins. 1. Alright, so that pin's ground. I got these outputs here. I shouldn't be touching this so freely, but it hasn't been plugged in for a while, although it's about to get plugged in. Interesting. So ground. I'm going to guess that the center pin over here is ground, since these are the two motor outputs, so they're going to be similar. Oh, I got the scary bits. I don't know how friendly I want to get with this. Oh, I didn't check these though. These are going to jumper straight over, so my assumption is the opposite side is going to be the same. Huh? Oh, I'm not touching. Yeah. All right. Just double check before I write it down. All right. And then should be this one here. So I don't know what I'm going to look for beyond the power supply. I don't think there's anything on here that's labeled fuse. But while this is at least mildly safe to touch like this, I should check. I think this little thing here is a fuse. Alright, well, if it's a fuse, power can go through it. Let's check with my eyes. This here looks to be a bridge rectifier. A full bridge rectifier. I see no nasty burns or scarring on any of the surrounding components. Nothing went explodey. There's no charring on the PCB. I don't even know where I am on frame. I'm kind of on my knees looking at this. Hands are a little shaky today. I'm not sure why. Probably need coffee. I haven't had coffee for a couple days now. Weird. Yeah, I don't see anything. Where are you going? That looks to be scratched, but yeah. I don't know what 4M0 means. RW1. I wonder what RW stands for. Clearly not resistor, because there's a bunch of other stuff that's labeled R. 1, 2, whatever. Unfortunately, I don't think I'm going to be able to fix this, because I don't know what I'm doing. I really shouldn't be poking and prodding at this even, but if I don't try something, I mean, there's not much I can do. And I'm the one taking the risk, so yeah. I don't recommend doing what I'm about to do. If yeah, in general, I don't recommend it. So what I'm going to do is I'm going to set this back in its housing and I'm going to plug it in. I'm just going to use this to hold it while I plug it in, so I get a good firm grip and not have the PCB lift up on the board, or the housing, that is. Alright, so the question is, will I see any power? And the place I'm going to check, this is plastic by the way, is right here. So these top two pins are going to be ground. I suspect these bottom two pins are going to be power. And it should be DC. I would suspect it's under 20 volts. I don't have my nice auto ranging meter. This one has the probes taped up, so it's a little bit safer, or at least causes a false sense of security. So I got no voltage. And power strip is on as far as I know. We can go poke at the spookier bit. I don't like poking on the high voltage side, but let's see here. Yep, got 120 coming in. So the question is the voltage path. And it looks like, oops, I'm going to use this end. The pin side has a metal tip, so I'm going to use the plastic side. It looks like it kind of goes in and swirls around this way, because this side is DC coming from the control board after it goes through all the high voltage stuff, and then yeah, powers the control board. Oh, I just don't like poking around some of this stuff because it's kind of scary. what I don't understand is what all these different wires do. So this two wires here from this connector feeds back into the motor control, and it looks like some of these Onyx is being naughty. Some of these feed back into here, and I'm assuming that is so the motor can communicate its position with the main controller board. So you got like the main AC power here, and then I think this is where all like the DC voltages are fully done up. That's going to be my guess. But if we're not getting any power in through here, then that means something in this part failed, which gets a little bit scarier for probing purposes, at least for me as an inexperienced person. I don't think. I mean, it's not like this is going to be putting out 200 volt or above 20 volts. Yeah. So we know the line voltage is coming in through the plug. There's not going to be voltage here because this is the motor power. We know this pin's ground pin. That's a diode from the looks of it, so I can't really figure out. I guess this is kind of the scary side of things. I don't like this side, and I need to be on AC voltage on this end. I could probe the full bridge rectifier. 120 volt sparks aren't bad. I'm definitely gonna scream like a girl. So based on the look of it, the two pins in the middle are the input of the full bridge rectifier. So we got one side which is hot or neutral. I don't know which one's which. I would guess this one's actually hot because this is the fuse right here. So on the outside pins, I should be getting 120 volts DC. Alright, so for safety reasons, it would be nice if these wires weren't all tangled up. And I'm going to probe this and then look at the meter because my hands are too jittery. 168 volts. What the heck? Why is that voltage higher than the input? I don't remember what's before that full bridge rectifier anymore. 122. I don't think there's a transformer in there. There's some filter caps and stuff. Question is, where do I probe next? A lot of this stuff's really close together, and I don't like that. And I don't know what to expect. Probe there and to ground. There's nothing there. I'm going to turn off the power and see if that's a ground or something else. Alright, so that's a ground. I don't know what that is, and I'm not going to flip the board over to test and see because it probably still has some of it charged. We go back to DC voltage and check the full bridge rectifier for voltage. Yeah, see, it's slowly discharging. That's why you don't want to touch stuff after you unplug it. And just watch. I think the meter's in view, but yeah, we're down to 40 volts when I last touched it. Oh yeah, it's in view. Should be readable. What I could do is I could turn on power and then turn it off and then check for voltage, because then at least it's not going to have the full blast of power going into the board. It's just going to have whatever charge is left in the capacitors, which will still make a fun spark, but not quite as fun as 120 volt 10 amp or however much this cord can pull before something bad happens. I think I'm gonna grab my hot stick though, and I'm gonna use that to see if I can determine any voltage inside. Alright, so I have my hot stick, technically called a non-contact voltage detector or whatever, but so it's gonna light up there. This is the neutral, that's the hot. It's gonna light up here, because that's the full bridge rectifier. Lights up there. Doesn't light up here. There's 120 volts going through this section. It's probably stepping down the voltage or something. But here, I don't know if I would see anything from the hot stick, to be honest. So none of that's live. So we know voltage is here. We know voltage is here. We know voltage is here. Next step is figuring out if there's anything there. And I think if memory serves correct, I probably should have taken pictures of both sides before I started doing this, because my memory's not as good as it should be, and I don't remember flip-flopping and everything what I was seeing. But I believe based on this pin configuration, I think the transformer was right there. So I'm going to kill power. I would unplug it versus turning the power strip off, but I'm too lazy to hold the cover down on top of it, so I can unplug it and make it safer. I think I'm going to look for more grounds. Alright, so I think, oops, go back to continuity mode. I think this big pin here might be good. Ooh. That's not a good sound. I wonder why it's making that sound. Let's go AC voltage. No AC voltage there. DC? A little bit of DC voltage. I've never heard it make that sound before. So there's something going there, on right there, that thing for voltage. I don't know what. There's this thing here. I think it might be an inductor, maybe. I don't know if the lowercase m is like referring to like millihenry, whatever. I don't think this is a fuse. I don't know if it is a fuse or there's power, or I could send a voltage. I don't know. It passes continuity test. That's what I'm trying to say. Golly. I mean, if it's a resistor, it's not gonna have very high resistance. No, I don't think this can do inductance. Oh, it says 200. Oh, that's millivolts. That's like 200 amp. All right, there we go. Oh, lower resistance. No. Alright, well I think I'm going to turn power back on. Probe that point to a known ground. And my expectation is AC voltage. So this is live again. Now we got the hot stick. So we're going to poke right here. I've got no AC voltage. Let's check for, well, I guess there wouldn't be any AC voltage because everything past the bridge rectifier is going to be DC. 64 volts basically. I think I want to probe these mystery pins here, but I should probably label that pin here. Ooh, watch the finger. If I'm not getting any output here, I don't expect anything to be here because that basically directly connects to these. So these two pins here, the bottom two, should be the voltage output. But let's see what we get. I gotta be careful. Oop. Oh. Oop, slippery. So I got nothing there. I need to find some more points that I can poke that are safe. Alright, I'm gonna go ground to this pin here. Ooh, careful. Spooked myself. So that's showing 100 volts. Actually, I'm gonna just leave it powered on. So there's this spot here that's that has no traces. I think that's the isolation gap between the line and voltage input side to the DC output. Huh. Blink, blink, blink. That's interesting. I wonder why that's blinking. I wonder if that's an indication that it's like pulsing power and the power supply is like failing to initialize or whatever the heck these kinds of power supplies do. Once you get further in, but right here, I think though there's a transformer here because I wonder if the transformer jumps the gap, basically this barrier to protect the higher voltage from the lower voltage. I feel like there's a capacitor or something across here because I could see the row of pins. That would make sense for a transformer, and it's just going to be 1, 2, 3, 4, 5, these 6 pins. So everything in front of the tip. These two here, that's weird blinky. I don't know what that would be. Wish I had a better photographic memory, I guess. I'm going to check across this here for voltage. I got nothing. What about these 2 pins that are blinking? Alright, gotta be really careful. It's fluctuating faster than that meter can pick up. Alright, so I'm going to turn this off and do something a little risky. I wish I had a way to drain this a little faster. Let's just check this for voltage real quick. 120 and dropping. I want to see. It's probably something I have to like stop the video and Google, see what it means. But I don't fully understand like switch mode power supplies and all the different types of power supplies. But I think with like if this were a switch mode power supply, I think the speed that it switches would probably be something faster than what this can pick up on. But I don't know. I have no clue what I'm talking about half this stuff. Alright, so we're mostly down on voltage. I think what I'm going to do is I'm just going to flip this over and hope it falls nicely in its place. So I think the blinky part's over here. This is now inverted. Oh, okay, those row of pins were probably the opto isolator. I don't like this, but here's what I'm going to do. I'm going to put this haphazardly back on top and flip it back over. Alright, so that makes a little more sense. This nice neat row of pins is all those opto isolators. Also, we've flipped this around from the way it was, but oh well. So it was this way. Opto isolators. Alright, I'm gonna unplug the figure 8 cord, or not figure 8, Mickey Mouse cord. I don't really want to touch the PCB, so as I just run my fingers across the bottom of it, trying to pick this up, I'll hold you in place. Is that good enough? Yeah, it's good enough. That's one way to handle this without worrying about getting shocked. So blinky bit was right here, which translates to something here. Be funny if it was that capacitor, that diagonal green capacitor that is now in the middle of the screen. It's labeled C3, but the C is upside down. I wonder what this is. More capacitors. I don't know what the type of capacitors those blue ones are. If they're like filter capacitors or if they're even capacitors. CY. So I think those might be like surge protectors, maybe? MOVs. I do see where the capacitors are now, though. I don't think voltage is getting to the other side, though. What I think the most likely scenario is the transformer exploded. And some of the windings are bad. Just trying to look at this without electrocuting myself. I don't think transformers really have a smell to them when they go bad. Huh. I don't know if it's supposed to be like that. I wonder what the odds are that the transformer blew up and shorted itself out. What's sad is I don't even know what voltage this whole system runs off of. I could probably figure out how by reverse engineering and looking at some of these components and get an idea, especially with those transistors that are probably voltage regulators. I think what I'm going to do is unhook these. It's probably discharged by now, but I don't really feel like getting shocked today. I don't ever really feel like getting shocked, but you know. So, just gonna use this housing as a support so I can plug in the power properly. I probably shouldn't be lifting this up by the jack in all honesty, because it's gonna be kind of flimsy. Alright, we're gonna energize this without the controller board. Kaboom! So where am I going to poke? I think these two big pins here are the inputs for the transformer here. Because these are the outputs. And those are the only two good sized pins around. So we'll go to DC input, or DC voltage. Make sure it's in frame, yep. Be mindful here, be very careful. Well, there's no DC voltage. Check for AC. It's weird. No. I don't know why this was wrapped around the multimeter's probes were wrapped, cables wrapped around it and it was flashing when I touched it, but I think I was just bumping it. I don't know if you're supposed to do continuity testing with power on there, so I'm going to turn that off. So we know this is ground. Well, those aren't happy. I know this is ground. Yeah. I don't understand why these all have a path to ground. I don't know if it's supposed to be like that or not. Because these don't. Just looking here. Kind of see where the traces go. Well, those don't have a path to ground. I feel like the bottom two pins. Well, I don't know. I can't really tell where these are going. Is this all? It scared me. It should be discharged by now, but I think it's a single-sided PCB. Oh, okay, and I can see where the ground stuff all lines up. It wasn't live, but yeah, it scared me. I don't think we're going to see higher than 20 volts if there's power going through. This is the ground side of the capacitor, so the other side should be the positive side. And there's just no voltage. I think, in my totally amateur opinion, this transformer shorted itself out and blew up. Because there's no reason why those 4 pins... Turn this off again. Good. There's no reason why these 4 pins should all show continuity with each other that I can think of. I don't... Because, I mean, you can tell in the traces that they're isolated. They're not connected. Not directly, at least. But, it all shows continuity. And it all runs back to the ground pin. Versus this other side, it doesn't. But I also can't really tell. I guess there's only 2 pins for the input side of the transformer. Put power back on here. AC voltage. No. Actually, yeah, let's do AC voltage. Let's check the feed. 122 volts. And then on the outside of the rectifier. Oh, I'm going to be DC. So we got 122 in. And 168 out. I don't understand that. I might have to go ask AI a question on that. And then there's nothing here. Let's go back to ground. Oh. There's nothing there because they're both getting 100. What? How's that work? Are there other pins for the transformer? I think this giant pin here is a wire that goes to ground. Oops. Yeah. Yeah, that's not connected to the transformer. It's like a ground wire for the other side of the circuit or something. I think I'm going to ask AI some questions and see what happens. Alright, so I learned some stuff, and if you've somehow made it this far even, you already know I'm dumb. So, that's whatever. But, so I guess a couple things. The output voltage of the bridge rectifier is fine. I guess that's normal to see 168 volts after diode losses and something else. But basically what's looking like is there should be a pulsed voltage there, not DC. And I don't think my meter's good enough to really tell one way or another. So, oop, in the wrong mode. It's angry. Apparently it doesn't like voltages in continuity mode. But, yeah, so that should be pulsed. I don't know how to check that without an oscilloscope. But, ChatGPT seems to think the switching side of things is what's wrong. So it's giving me some suggestions. Just realized I don't know what drain to source is. I think source is the center pin of a MOSFET. Then check for resistance on the MOSFETs. Gate drive circuit. That IC chip. I'd have to check for power. I have no way to check it for pulses without an oscilloscope. I'd have to know the pinouts. And then transformer. So apparently the MOSFET can be stuck on. I'm sending DC instead of pulsed AC. Check switching element. Should never have pure DC applied, so the multimeter would not read AC correctly unless the pulses are strong or frequent. I don't have an oscilloscope. And check for blown protection components, which I don't really know what to check beyond the input fuse. Startup resistor, I don't know which one of these is the pulse width modulation IC. It could be this one right here for all I know. But it's saying MOSFET failure, gate drive failure, or pulse width modulator controller failure. It's just weird because I would have expected to see something exploded if it was one of these chips or pieces of silicon. So there's a MOSFET there, I guess. That would be right next to the input side of the transformer. I don't know if normally that would be close or not. Gotta look at this with my own eyes. D3. Label on the top side. Q1. See Q2, Q11. What? It definitely says Q1. Q5. I don't think, no, they didn't label the bottom side stuff. Okay. So how do I determine where those pins are? So, spread out. They all look to be in a row. Yeah, they're all in a row. Well, where's the third pin at? That's weird. So I think these two pins right here, the ones that D3 is labeled, this D3 labels here, and then 2 pins around it. I think those are 2 of the MOSFET pins, but I don't see where the third one goes because they should all be in a row. They're not bent, so like this this pin here, like those aren't the 3 pins, and this is just a pad that's been soldered over. I don't know what pin of IC2 would be the pulse width modulator controller IC. So I guess what I'm going to do is I'm going to see if I can figure out which ones of those pins are ground. Let's make sure this is dead first. Alright, I have it off. It's going to be so hard to do that with power. Those pins. None of those pins go to ground. I get this closer to my face. Weird. Continuity's working. Alright, I'm not going to be able to show this on camera because I need it closer to my face so I can see what I'm doing. I'm going to start checking for voltages. It says 10 to 20 volts. No, it's not that one. Not that one. We'll do the outside pins first. It must be higher than 20 volts. Negative 63. Negative 50. That's wrong. Get negative something or other voltages. Let's careful. God, I'll short it out. Hands are too shaky. Huh. Alright, well, all the pins except for one that's down one from the top right side are showing negative 63 volts. I'd really like to figure this out, but I don't think I'm going to. I guess I'm going to have to ask AI some more questions, maybe. I wish... Turn this off so it's somewhat safe. I wish there was a way I could figure out where that MOSFET's up to. I need like a non-conductive tool that I can use to pick the fancy glue they put on these things away. Fingers. Make a little taco out of this. Yeah, so all that white crap over the transistor near the transformer, if that wasn't in my way, I could see a little better. Oh, actually no, alright, the leg is bent. It's so hard to see because I mean it's just kind of nestled in there and like you kind of have to look through the crap. So I guess if I can finagle this without touching anything bad. There we go. So that triangle of pins was what I want. I'm going to Google what the source and the gate is and all that on a MOSFET first. I think the center pin's the source though. Alright, so top pin is source. The center pin is drain, which be that one there. And the bottom one is gate. So none of those should have any continuity. Let's make sure this is fully drained first, like the internet said. Do 1.6 volts. It's drained enough. So none of those pins should have continuity to each other then. Okay, yeah. Check for short circuits. Huh. And then check for resistance. Should be low resistance if it's failed. Wait, why does it say negative? Drains the source. It shows extremely low resistance. So the MOSFET's bad? It shows 0 ohms. Source drain gate, or is it source gate drain? I don't know. It shows 0 ohms to the center pin. Unless that's too high for the range. I mean, I'll go up to 20K. 0. 2K. 0. But here, go to 200 ohms setting down. Shows 5 ohms. This is extremely low resistance. I wonder how picky these MOSFETs are with which one I use. I'll grab a glove. This is not an electrically rated glove, but it gives me a false sense of security. Woo! How hard that would be to pry out. I don't think this screwdriver is electrically insulated. The handle should be, but the shaft goes all the way through to the end. Should be no voltage, but this cap right here is probably really spicy. Let's find out. That would be filtering DC voltage. It appears to be drained. Either way, I'm going to try to be careful. Could also poke it with this, although I don't think it'll show anything since it's not getting power. Whoo! Yeah, we're just going to put my hand right over that and, you know, see if I can unscrew this. Unfortunately, I'm just going to let the screw fall out. Probably not the best move, but it's the best I got. I think normally when it comes to these power supplies, these heat sinks are not grounded. Yeah, they're line voltage, if anything. You know, or they would have voltage going through them, that is. Don't take anything when I say is word or gospel, because I have no clue what I'm doing. I've watched some videos, and that's about all I could say. That transistor, or that screw is stuck in the MOSFET. Well, it's weird. RT2. So under all that goop, there might be a thermal probe. I don't know how to get that off though. I should probably screw the screw back in, and that way I could pry on it without prying on the MOSFET. Pretty sure it's a MOSFET at least. Oh! That peeled off in an interesting way. Wish I had some tools that were more suitable for what I'm doing here. I'm trying to pry that loose. I got it mostly loose. Of course, I'm using my conductive screwdriver like a genius. So I'm going to have to desolder this, I think. And see what I get. It's a shame this MOSFET's necessary for circuit function. Alright, I'm going to see if I can remove that MOSFET and see what it is. Well, some time has passed, and yeah, learned some things, and I've made some mistakes. So the reason why these pins on the transformer are all showing continuity is, well, for starters, they're tied together in pairs, but I couldn't see when basically this is here and my head's like down here at the same angle, so I'm looking at sideways trying to do that. But then also good transformer coils, I guess, will show continuity, which I never knew because I've never needed to test the transformer before. Same with this end, showing continuity. I did remove this MOSFET, which yeah, you're not gonna be able to see what it says on camera. It's a K14A65W. Unfortunately, I don't have one of these, obviously. But on top of that, I was thinking, you know, maybe I just steal it from a different power supply, like a random computer power supply or whatever. But from what ChatGPT is telling me, that if it's not the same spec, it's not ideal, basically. And I don't really want to buy one of these and find out that there's more wrong to this than just this MOSFET. But this MOSFET is bad because, let's see, drain to source, gate to source. It's in continuity mode. So I have a picture here of the pinout, which is basically the same for every MOSFET as far as I can tell. But yeah, so even out of circuit it has continuity. And I believe source to gate was 5 ohms. So that's not good. Odds are the MOSFET has failed though. Yeah, I don't know. It says if the MOSFET has failed, it often shorts drain to source. Yeah, I don't know what's going on with that. But unfortunately, that's probably gonna be as far as I get in this video. It's already overly long. The connectors, I did notice, are labeled, so I might be able to replicate that voltage with some bench power supplies that I have, but I don't know what H1, H2, and MCU do. I don't know. And see, this board has multiple layers, although it looks like, the majority of the bottom is just one big ground plane. Because I believe, oh, well, the wires are colored. I should notice that as well when I was poking around. But these two pins are clearly ground based on the black wires. And it's probably labeled in the power supply as well. Yeah, so ground. The black wires are ground. And you can see they're tied. And this big sheet of copper loops around and, oh, focus. Goes to the one pin that I thought was ground wire. Or ground pin was grounded. And then, yeah, this whole bottom area here where all the green is, the lighter green, that's all copper with coating over it to insulate it. But yeah, just looking here. Interesting. ZL, what does that do? Oh, okay, that's just the back feeding the power to the motor. Interesting. So I almost wonder if I could feed this board power. I wonder if I could skip out on the 33 volt, because I suspect that's just purely going to these relays. which are probably controlled by these transistors, which jerks, which appear to have been completely etched smooth. But I think if I were to just energize this part of the circuit, I could see if I can get the display to light up, and then I would know if this is fried or not. But yeah, I think that's kind of where I'm stuck right now until I figure out what to do about that MOSFET. I have one that's close, but the capacitance is different, which apparently matters for the switching speed, which if the switching speed is too slow might cause instability and other issues, I guess. I don't know. So yeah, I have no idea what to do from here. And odds are by the time this video goes live, I might have actually tried something. Really, the only thing I can do would be I could put in a random MOSFET in there that's close enough and just kind of hope this doesn't explode. Otherwise, I don't think there's really much intelligence on this end of the power supply that communicates with the brains. I mean, there are pins that go from the power supply to that, but let's see. MCU ground. So it's the outside 2 pins. So you got 2 pins there and then 2 pins there. H1, H2. No clue what that means. And then the MCU pins. Those appear to be pins that go to the MCU motor control unit? I don't know. Why would you call it a motor control unit? I don't imagine the motors in the desk have any intelligence. Definitely not Marvel Cinematic Universe. Although you never know. Huh. I don't know. I think what I could do is I could risk putting in the wrong MOSFET and then just hope this doesn't explode. And if it does explode, well, I just have to make my own power supply. I don't know. But yeah, if you somehow made it this far, I'm amazed. And thanks for watching, I guess, because I didn't really accomplish anything. But maybe this lays the groundwork for other people that have these that are dead. Or if anything, you could see how a total amateur diagnoses something they don't understand. So either way, thanks for watching.